Okay, the place where we had ended up yesterday is we had just determined that cos of the angle, if you plugged that into a calculator, you would get the x-coordinate. If you did sine of the angle, you would get the y-coordinate. If you did tan of the angle, you would get the y-coordinate divided by the x-coordinate. So I want to talk about that some more. You have these buttons on the calculator right here, sine, cosine, and tangent. And you probably used them in Math 2 when you did SOHCAHTOA for solving right triangles. Do you guys remember doing that, SOHCAHTOA? You probably had two angles or two sides of a triangle. Maybe you found the third side, or an angle in a triangle. Maybe you found a missing angle. If you had one angle and one side, something like that. Does that sound familiar, having SOHCAHTOA? Maybe you had some word problems and they said something like angle of elevation or angle of depression, and then you did SOHCAHTOA problems, something like that. And when you used these three buttons, it was really important to see what mode you were in, and you would press this mode button right here. And then it would matter if you were in radians or degrees. And students always, once we start getting into trig, students are always not sure about which one they should use. They're not sure about if they should use radians or degrees, and then they start to be confused about when it matters if they're in radians or degrees. So the only time that your mode matters is if you actually hit one of those buttons when you do a calculation. If you're not going to touch one of those buttons doing a calculation, then your mode does not matter, okay? So unless we actually touch one of those buttons, we don't care. Now, if your problem has a bubble in it, you should be in degrees. Typically, if it has a pi in it, you're going to be in radians. But basically, if it has a bubble in it, you're going to be in degrees. And if it doesn't have a bubble, then you should be in radians. That's how you can tell what mode to be in. All right? So what we're going to do is we're just going to verify that some of these different things are true. We're going to stick with radians because radians are the most common. So I want everyone to hit the mode button. Make sure that your calculator is dark on radians. So everyone's calculators should be in radians. Is that what your guys' calculators say? Yep. Okay. So now to get out of this screen, I'm going to hit second quit. Second mode, second quit to get back to this regular calculating screen. And then if I wanted to see what sine of pi 6 was, I'm going to find out that it's 1/2 because that's the y-coordinate. But I'm going to hit sine, the sine button. And then I'm going to type in pi divided by 6. Pi is right up here. So I'm going to hit second and then the up arrow right here. Second up arrow divided by 6. And the calculator is going to tell me 0.5. It's going to give me the decimal of 1/2, 0.5. So sine of the angle is the y-coordinate. Everyone get that? Okay. If I try to find cos of 3 pi fourths, the calculator is going to give me the decimal for negative root 2 over 2. So I'm going to type in cos 3 pi divided by 4, cos 3 pi divided by 4, and the calculator gave me negative 0.707, and if I type in negative root 2 divided by 2, that is the same decimal. If I want to find tan of 5 pi over 6, tan of 5 pi over 6, it's going to give me 1 divided by root 3, or 1/2 divided by root 3 over 2. You'll see why I did lazy math in a second. So negative 0.577, it's going to give me the y value divided by the x value. So I'm going to type this one in as a fraction since I've got a lot to divide here. I'm going to do alpha y equals, and I'm going to do the y coordinate divided by the x coordinate. And you'll see it gives me that same decimal. So the reason people use the unit circle instead of a calculator is because if you were to use a calculator to evaluate these values, you would get irrational numbers. You would get decimals that have to be rounded before they can be written down. If you use the unit circle, you get exact values. You get irrational numbers, but you get them written as exact values. They're much easier to work with. You can do them to a greater degree of accuracy and precision, and they keep from getting too messy in problems. That's kind of the benefit of using the unit circle. All right, so what we're going to do now is we're actually going to start evaluating some numbers using the unit circle. And so if I ask you to find cos of an angle, you're going to say, okay, cos of an angle is that angle, but I'm going to use the x-coordinate. If I ask you for sine of an angle, you're going to say, okay, I'm going to find that angle, and then I'm going to use the y-coordinate. If I ask you for tan of an angle, you're going to say, okay, let me find the angle, but I'm going to take the y-coordinate and the x-coordinate, and I'm going to divide them. Does that make sense, how we're going to use it? Okay, so we're going to take this paper right here. We're going to flip it over, and we're just going to write some example problems on it, okay? So down here, you can write evaluating the unit circle. And when you evaluate using the unit circle, you can do the problems in radians or degrees, but I'm going to do them in radians just because that is going to be the most beneficial to you guys. But just know all these problems we could do in degrees as well. Okay, so the first problem that we're going to do is we're going to find cos of 7 pi 6. Cos of 7 pi 6. So you're going to locate 7 pi 6, you're going to find the x-coordinate, and that is going to be the answer. You're going to locate 7 pi 6 on the unit circle, you're going to find the x-coordinate, that is going to be the answer. So what is the answer? Negative root 3 over 2. Okay, for the next one, we're going to do sine of pi. Sine of pi. So you're going to find pi, find the y-coordinate, and that is the answer. What is it? 0. Okay. For the next one, we're going to find cos of 3 pi fourths. Cos of 3 pi fourths. What is cos of 3 pi fourths? Negative root 2 over 2. So we looked for 3 pi fourths on the unit circle. We looked at the x-coordinate. That was the answer. Okay. For this next one, we're going to look for sine of 11 pi 6. Sine of 11 pi 6. It's negative 1/2. So you're looking for 11 pi 6, and then you're looking for the y-coordinate. Okay? Next, I'm going to give you a slightly tricky one. This one is tan. So why did I say this is slightly tricky? You have to divide the y divided by the x. Okay, tan of pi fourths. Tan of pi fourths. So your calculator should not be used for any of these. Your calculators are dead to you today. No calculators. I know, it's sad. No calculators today. You don't need a calculator for this one. So tan of pi fourths, what would that give you? It would give you 1. So tan of pi fourths for this particular problem, the x-coordinate and the y-coordinate are exactly the same. So you have root 2 over 2 divided by root 2 over 2. Same thing divided by the same thing gives you 1. Okay? So the nice thing about that particular coordinate is that if you find tan of pi fourths, you're going to get 1. Tan of 3 pi fourths is negative 1. Tan of 5 pi fourths is 1. Tan of 7 pi fourths is negative 1. So we found out that even though tan is a little bit intimidating, a bunch of the answers are 1. So those answers are pretty easy. Okay, so that's something to file away in your brains for later. I want to show a little bit more work in this one so that we can see what's going to happen on all of these problems with the denominators. So anytime we do a fraction divided by a fraction, we keep the top fraction, we change it to a multiplication problem, and we bring the bottom fraction up and we multiply by the reciprocal. You might remember keep it, change it, flip it when you're dividing fractions. And then what ends up happening is these 2's cancel out. Those are the denominators from the 2 fractions that you're dividing. So the denominator here and the denominator here, when you end up dividing these fractions, these 2 denominators end up canceling out. And that's actually going to happen for every single one of the tangent problems. Which means that when you do a tangent problem, you can basically pretend that those 2 fractions don't have denominators because they would cancel out every single time. So now that I've done these problems for a long time, I've been doing these a lot longer than you guys have, that's why you heard me slip earlier and I said 1 divided by negative root 3, because I always pretend they don't have denominators, since I know that those denominators will cancel out. So if I was to look at pi fourths, I, in my head, ignore the denominators and I just say root 2 divided by root 2. If I was to do tan for pi 6, I would say 1 divided by root 3. If I was to do tan for pi thirds, I would say root 3 divided by 1. I always ignore the denominators because they cancel out every time. So it makes it a little easier. Yeah?
You said that most of the answers are 1, but...
The ones that are 1 are the ones that are the same. So the pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths are either 1 or negative 1.
Oh, okay.
Yeah. Yeah, the signs, yeah. Okay, so this one ends up being root 2 over root 2, which is why it's 1. Okay, let's look at another problem. For this one, let's do cos of pi over 6. Cos of pi over 6. What are we getting for cos of pi over 6? Root 3 over 2. So we located pi over 6. We found the x-coordinate. We write it down. Okay? Let's look at sine of 7 pi over 4. Sine of 7 pi over 4. You're close. Oh no, you should be right on. Negative root 2 over 2. Perfect. Okay. Let's look at tangent of 2 pi thirds. Tangent of 2 pi thirds. Mm-hmm. Mm-hmm. So for tangent of 2 pi thirds, we have root 3 over 2 divided by negative 1/2, right? We would do keep it, change it, flip it. So keep this one, change to a multiplication problem, flip this one. The 2's are going to cancel, right? Because they're always going to cancel. We can basically always ignore them. And then we end up with a fraction where we have a root 3 on the top and a negative 1 on the bottom. Anytime you have a 1 on the bottom of a fraction, you don't really need the problem to be a fraction. You can say that that problem is just a whole number. So it's going to be a root 3 with a negative sign in the front of it. So tan of 2 pi thirds is just negative root 3. This answer happens for 2 pi thirds, negative root 3. Positive root 3 happens for pi thirds. Positive root 3 happens for 4 pi thirds. And negative root 3 happens for 5 pi thirds. So all of the thirds are kind of nice tangent answers because you end up with something that's just divided by 1. You can ignore the denominator of 2, and you can say, oh, it's just a root 3 divided by 1, or it's a root 3 divided by a negative 1, or it's a negative root 3 divided by 1. The signs are different, but it's just something divided by 1. Does that make sense? So even though it's a tangent problem, even though it's a fraction with the y divided by x, it ends up being a nice answer. Does that make sense? Can we see that? Okay. That was the thirds. All the thirds. But the one we just did was tan 2 pi thirds. Okay, let's look at tan of 3 pi halves and see what that is. Tan of 3 pi halves. Tell me what that is. Tan of 3 pi halves. Not 0. Not negative 1. Undefined. It's undefined because what numbers are you dividing? Negative 1 divided by 0. Can't do that. That's undefined. Okay. All right, we got one last tangent answer to try. We're going to do tan of 5 pi over 6. Tan of 5 pi over 6. No. It's a tangent, so it's not going to be a typical one. It's not going to be negative root 3. So here, now we have to think back to our Math 2 days. So tan of 5 pi over 6 is going to be the y divided by the x. What's the y? 1. And then what's the x? Negative root 3. Okay. And we're ignoring the denominators. Now, back in Math 2, we learned that it's not proper to leave a radical on the bottom of the problem. We can't leave it like that. So in Math 2, we would have multiplied by a fraction, and we would have multiplied by something over something to make it so this didn't have a radical on the bottom of the fraction. We would have multiplied it by root 3 on the top and root 3 on the bottom. And we did this also when we were doing the unit circle the other day. We did it when we fixed the root 2's. Okay, so what do we get on the top? We get just root 3. And I'm going to take the negative. I'm just going to move that out to the front of the answer. And then what do we get on the bottom? We get just a 3. So root 3 times root 3 is root 9. Root 9 is just 3. Okay, so negative root 3 over 3. So this is the answer that with tangent is like the worst case scenario. This is the worst that it gets. So anytime you have a 1 over negative root 3 or a 1 over root 3, any of those on the unit circle, these are going to be the sixths. 1 over root 3, 1 over negative root 3, that's a 5/6. 7/6 is going to be a 1 over 3. 11/6 is a 1 over 3. All of those are going to be your root 3 over 3s. So on my paper, I'm going to write that this was 1 over negative root 3, which becomes negative root 3 over 3, just because we're writing it proper. Okay, how do your brains feel about those problems so far? Brains feeling good?
Could you connect them like on the big on the unit circle? Right.
Yeah, if you wanted to, I wouldn't put it on your normal unit circle because you need to be able to do them quickly in your brain. But if you wanted to do like one of the unit circles that you don't, well, I guess you could put it on here because you're going to end up memorizing it. But if you wanted to say like, this is negative root 3 over 3, this is negative 1, this is negative root 3, this is undefined, this is positive root 3, I don't think it's beneficial for you to have all these though, because then you don't have to think about it, and then you'd have to memorize them instead of being able to look at it and think about it. I don't know. I'll write them down, but I think it could be dangerous to have them written down. I think it might be too much of a crutch. This would be 0 divided by negative 1 would be 0. So these two are 0 instead of undefined. This one is negative root 3, negative 1, root 3, 1, root 3 over 3. Okay. How do your brains feel about those three trig? Could you learn about other ones, or would you feel overwhelmed? You'd feel overwhelmed? Okay, here's what I need you to do. All right, here is the first one you're going to do. Tangent 7 pi fourths. Tell me what tangent 7 pi fourths is. Write the answer down. Hold it up. Yes. 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 Wait, what is that? Did you put it sideways? Oh no, I see it. I see it. It was the crack in the board. I got it. All right. Yes. All right. Here is the next one. Gonna make you think with this one, okay? You ready? Cos negative 3 pi halves. Cos negative 3 pi halves. Yes. Yes. Yep. Yes. Yes, 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 yes. Thirds. Tan, negative pi thirds. Wait. Yes. Yeah, yes, sorry, I hurt my brain. I hurt my own brain. Yes. Close. Yes. You underlined it? No. It's just as close as it was before. Yes. All right, sine 11 pi fourths. Sine 11 pi fourths. Sine 11 pi fourths. Sine 11 pi fourths. You're good. Come up and grab. Yes. Come up and grab the homework. Yes. 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 Somebody tell us, what was the easiest way to do that problem? Yes. Count the fourths? Okay.
Well, I just went to 12 fourths and went back.
No. No, because it's a sine. It's not a tan.
Oh. I can't write it down, but then I think.
Did anyone use their calculator to find a coterminal angle? Yes.
No, I just went around to 12 fourths because that would be
11 fourths minus 2. Oh, it's the same thing as 3 fourths. Yeah, it's just a coterminal angle. Ah, Miss Rice, that was tricky. All right, let's do sine negative 23 pi sixths. I literally just showed you the strategy. Sine negative 23 pi sixths. You're close. You're close. You're close. There you go. Yes, very close. Yes. No, yes. Delana, yes. No, you were better before. Yes. No. Yes. That's right. Not negative. No. All right, now you can count the sixth, or you can just find the coterminal angle. Plus 2, still negative, plus 2 more. Oh, that's positive 1/6. Look at pi sixth. Right? Easier way to do it. Okay. Let's find tan of 5 pi fourths. Tan of 5 pi fourths. Tan of 5 pi fourths. Yes. 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 Tan negative pi 6. Tan, negative pi 6. Tan, negative pi 6. Yes. Yes. No. Yes. No. I don't. It's like calling me by my first name. Yes. 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 No. Yes. 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 Sine, negative 5 pi 6. Sine, negative 5 pi 6. Yes, no. Yes, yes. Yes, yes. Yes. No. Yes. 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 Half right. Yes.
I'm gonna go with that one.
All wrong. Yes. Tan of negative 15 pi halves. Tan of negative 15 pi halves. Yes. Oh, put down your oh, no, I see what you're doing with calculators. I thought you were evaluating it. Yes. Yes. No. Yes. 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 No. Yes. Kind of, but what's the mathy word for that? Yes. Yes.
I can't spell. Wait a minute.
Yes.
My fifth grade spelling caught me.
I don't know.
Y. Y divided by X. Cos 5 pi over 6. Cos 5 pi over 6. Cos 5 pi over 6. Yes. 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 No. Yes. 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 No. Yes. 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 Cos negative pi over 6. Cos negative pi over 6. Cos negative pi over 6. Yes. Yeah, no. No. Yes. Yes. No. No. Yes. Yes. No. No. Yes. Yes. No. Yes. Yes. No. Yes. 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 Okay, how are we feeling about these? Fantastic. They are making sense. They are in our brains. All right, I have a special cheat sheet for you. A special cheat sheet for you. What I need for you guys to do is to erase the whiteboards nice and clean. So don't leave anything written on them because then they get all gross. And put a pile of them on one desk. Okay, so I just handed out this sheet. You basically never want to throw this away as long as you are ever taking a math class, because other teachers in future math classes really should hand out a sheet like this, but they generally don't. So I hand this out if I teach pre-calc, I hand this out if I teach calculus, I hand this out if I tutor somebody in any of those classes because their teachers generally don't hand it out. I often have students emailing me from college asking for this sheet. So basically don't throw it away because it's really nice to have all these formulas in one place. And I will always keep extra copies so that if you lose it, you can have it. But if you end up going on into a college math course, it'll be nice to have all of these. So you'll recognize right here sine, cosine, tangent. We've learned those. There are actually 3 more trig functions that you haven't learned that we're going to learn today that you might not recognize. The first one is cosecant. Everyone say cosecant. Cosecant. The next one is secant. Say secant. And then cotangent. Cotangent. Yeah, don't say cot. People look at you like you're funny. It's kind of like people who say sin instead of sine. You go like, ooh, that's a church word, not a math word. Okay, thanks. Okay, so the way that we remember these, they're called the reciprocal identities. What does reciprocal do in math if you have a fraction? What's the reciprocal? You flip it, yeah. So if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite, okay? So what I'm going to write right here is opposite over hypotenuse. That's what sine is. And then that means that cosecant is hypotenuse over opposite. So you just take whatever number you have for sine, whatever fraction or whatever ratio you have for sine, all you have to do is flip it. That's how you get cosecant. Cos is adjacent over hypotenuse. So secant is hypotenuse over adjacent. Tangent is opposite over adjacent. And so cotangent is adjacent over opposite. So that's why they're called the reciprocal identities, is you just take whatever the ratio was, whatever the fraction was, and you just flip it. That's how you find out what those are. So we're going to go back to our unit circle, and we're going to look at what some of these other trig functions could be if we're using them to evaluate some of these same things. At this point, if we need to write down some samples, where do you guys want to write them? Do we have space on our unit circle? Do we want to write it on this page? We could write it on the blue sheet. Where would you guys like to write them? Blue sheet? Okay, so I'm going to flip over the blue sheet. Here's what I'm going to write at the top of the blue sheet just so I can reference it. I'm going to say that sine goes to cosecant. That's the one it flips to give you cosecant. Cos flips to give you secant. And tangent flips to give you cotangent. It's good to remember which one flips to give you which one. Okay, so we're going to do some sample problems. We're going to say, what if I needed to find cosecant of, whoop, that's not what I wrote. What if I needed to find cosecant of pi over 6? So if I needed to find cosecant of pi over 6, I would look at the y-coordinate, because cosecant is just the flipped version of sine, and sine is the y-coordinate. So I would look at the y-coordinate, and instead of writing down that fraction, I would write down the reciprocal of that fraction. So I would look at pi over 6, I would take the y-coordinate, and I would flip it before I wrote it down. So flip it, I'm going to write it down as 2 over 1, which is just 2. So cosecant of pi over 6 is 2. Does that make sense? Okay. Here's another one. If I wanted to find secant of pi over 6, that is the reciprocal of cos. So I would look at pi over 6, I would look at the x-coordinate because cos is the x-coordinate, and then I would take the reciprocal of the x-coordinate, that's 2 over root 3. But I can't leave my answer as 2 over root 3, that's improper. So how would I fix this answer? I would multiply it by root 3 over root 3. And so on the top, I would have 2 and then a root 3, right? And then what would I have on the bottom? Just a 3. Okay, so that's a weird looking answer. Let's say I tried to do cotangent of pi over 6. Then I wouldn't do y divided by x. I would do x divided by y, because I would do the reciprocal. I would do the opposite. So if I did x divided by y, what would x divided by y give me? Root 3. So the tangent was this more complicated answer, but the cotangent was the more simple answer in this case. Okay. Let's try another one. What if I needed to do secant of 2 pi thirds? What if I needed to do secant of 2 pi thirds? I would look at 2 pi thirds, and then which coordinate would I take? The x coordinate, okay? And then what would I do with it? I would flip it, and so what would my answer be? -2, okay? Let's try another one. Let's say I was doing a cosecant of 5 pi fourths. Cosecant of 5 pi fourths. So for cosecant of 5 pi fourths, I would find 5 pi fourths. Which coordinate do I look at? The y coordinate. That's -√2 over 2, but what do I write down? -2 over root 2. I can't leave it like that. That's not proper, right? So how do I fix it? I multiply by root 2 over root 2, okay? And then what do I have on the top? Okay, negative 2 root 2 on the top. What do I have on the bottom? 2. Should I leave it like that? I could leave it like that, but what about the 2's? I could cancel the 2's. So negative root 2. And that actually kind of makes sense, because if we go back to, remember how we got the root 2 over 2 to begin with? We actually had 1 over root 2 before we fixed it. So if we think about what would happen if we had not fixed it, then this could have been the fraction 1 over root 2, and if you have the fraction 1 over root 2 and you flip that, then it would just be root 2. Does that make sense? If that's what you had and it wasn't fixed. Okay. Let's find cotangent of 2 pi thirds and see what we get for that. Cotangent of 2 pi thirds. So there's 2 pi thirds. Instead of doing y divided by x, we're going to do x divided by y. So I'm going to have negative 1 over root 3. So it's not going to be this answer. That's the tangent. What answer is it going to be? It's going to be the x over y, but I'm ignoring the bottoms because I know they would cancel. So negative 1 over root 3, and if I fixed it, what would it be? Negative root 3 over 3. Okay. So for our homework tonight, I have a blank unit circle for you to fill out because I know that's your favorite. Okay. And then I have some of these for you guys to just find the answers for. Sound reasonable? Can we handle this? Okay. I'm going to go ahead and hand this out. You can get a start on it.